Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hafizi bin Ahmad Lazim. My mentor number is AN190168. My supervisor name is Dr. Adami Kasani. So, for the title of my final year project 2 is the investigation of flame characteristic of a flameless combustor ignition system using a spiral nozzle. So for the abstract, nowadays combustion is one of the industrial process for the heating, drying, shrinking, and polymerize. Combustion generate hot air, which is subsequent channel to the select location for utilization. The purpose. So the purpose of this case study was to discover and learn the fire characteristic that occur when a spiral nozzle is utilized. The challenge. The problem that we face while while this project ongoing is the challenge of initiation of fire in the combustion chamber was one of them. So the research objective are to establish the best operating method for ignition and firing up the combustion chamber. So the experiment were carried out in the automotive lab of Faculty of Mechanical and Manufacturing Engineering (FKMP) during the project preliminary test. To conduct out this investigation, the experiment was carried out using premix, which means air and liquid petroleum gas (LPG) gas, and air pressure. For this experiment, an apparatus such as one LPG barrel, an air compressor pipe tube size 10, 2 flow meter for air and LPG, a spiral nozzle 1.5 inch, and a blowtorch to light up the fire. 5 thermocouple were employed with a 5 cm space between them. The research will be able to overcome the firing up problem during preheating as the result of this research damaging to the environment. The use of flameless combustion will help to extend the life of equipment by ensuring that there is no flame present in the combustion chamber. That was the significance of this case study. So, for the methodology that I conclude is flowchart. So the beginning of this section explanation the work flowchart of present study. In this section, test facility are described including the spiral nozzle. Then the instrumentation and measurement technique are present including the measurement using handput camera, pico logger, measuring tape. Image analysis technique used in this research is Adobe Photoshop. We using there are two type of measurement scale that are used for this case study. First is by calibrating an object using Adobe Photoshop and measuring tape. The flame combustor design and develop follow step the following step. For this step, SolidWorks 2019 was used to create a detailed sketch of combustion component. When the drawing was finished, there were parts that need to be produced based on the drawing. The prototype will be put to the test to see if any issue developed that will cause the data collection to be disturbed. So analysis will be completed in the last step before moving on to the thesis writing. In chapter 4 of this thesis, the acquired data will be carefully analyzed, present, and explained. So, for the result, there is 4 graphs that I provide, which means the first graph is the average temperature versus distance from nozzle. Next graph is maximum temperature versus distance from nozzle, and average length versus equivalent ratio, and maximum length versus equivalent ratio. So based on this graph, based on this provide graph and the equivalent ratio that been set up, the experiment data actually are not same with the theoretical data. This is because The air-fuel ratio for LPG was 1 to 15, which means one LPG gas, 15 air. So based on this story, supposed to be at equivalent ratio 1 is the most suitable data for this investigation. But for this investigation at equilibrium, ratio 1.33 was the most suitable data. For the temperature profile, the best operating condition will be selected on the data that show that least different from the distance from 5 cm to 25 cm. Based on the temperature profile for average at equivalent ratio 1.33, the difference are not more than 2 degrees, which means it was the the most lowest different temperature compared to the other graph. So the graph was supported by plotting the maximum temperature versus equivalent ratio. For the graph maximum temperature, the graph also showed a slightly different temperature measured profile compared to other equivalent ratio. So based on data above, the stoichiometry was at equivalent ratio 1.33. Above equivalent ratio 1.33, the mixture was a lean mixture, which means that air supply is exceed the gas supply. So that's why the temperature profile for equivalent ratio 1.67 and 2 show significant difference, which is the temperature drop at 20 and 25 degrees Celsius. For the mixture below equivalent ratio 1.33, which means that 0.33, 0.67, and 1, the mixture called as a rich mixture. So for the length, for the average length and maximum length, the graph also show that at equivalent ratio 1.33 is the most suitable length for this combustion chamber. This is because the length at equivalent ratio 1.33 is the most suitable due to the design of the combustion chamber. We cannot pick up the highest length of the highest length based on the plotted data, because when the flame is too long, it will touch the other part of the chamber, and if the flame of length is too short, the combustion chamber will become will not stable, because at equivalent ratio 2, it the flame will blow off. The flame will blow off because air is exit from the LPG gas, and the length are too short to hold the to hold the mixture LPG and air. That's for discussion. And so for the conclusion is the current investigation of flame characteristic of flameless combustion ignition system utilize a spiral nozzle effectively analysis flame temperature and length. So when the equivalence of ratio is 1.33, the flame average temperature that is suitable for the combustion is determined by the data analysis. The flame average temperature between 16.77 degrees Celsius and 61.53 degrees Celsius. The highest temperature for the equivalent ratio is 1.33, also constant and does not fluctuate significantly from the average temperature. On the other hand, the equivalent ratio at 1.33, the flame average length is 25.16 cm from the tip of the spiral nozzle. The 1.33 equivalent ratio has a maximum flame length of 30.8 cm. As the result, the flame equivalent ratio does not differ significantly. Overall, due to the flame at rich mixture, the usage of spiral nozzle for flameless case study is recommended. This objective for this investigation are successfully achieved by choosing equivalent ratio 1.23. The presence of spiral allow the flame to be maintained. Mean it is it if the flame is too lean, it will extinguish due to the air velocity that is supply disturb the line condition. So that's all for me. Thank you.